Yeah, it turns out the slope can be interpreted as what I have on the board here, the average rate of change. Let me just give you an example here. Let's say I've got a certain some data here. At age 6, a child is 45 inches tall. And then at age 13, the child is 60 inches tall. Well, what I want us to do here first is let's calculate the slope. So here's the question. What is the slope of the line that would join these 2 points if we graph them, okay? That's the first question. Slope of the line, if we join those 2 points, if we were to graph them. So, one thing is, let's go ahead and put it maybe in a more familiar form here. So I've got at age 6, it's 45. And so that, we can just interpret that as our x and y values. 6, 45. 6, comma, 45. All right? And then the other one would be what? Well, I've got 13, comma, 60. So you see there, yeah, I can just interpret these as x and y values. And then I can calculate the slope. I'm not going to actually graph these, but very well could. Graph these, put these on a graph. I just want the slope here, because that's what we're talking about at this point in time. Okay, so that's the slope formula. Just take the difference of the y's over the difference of the x's. One way to write it, y2 minus y1 over x2 minus x1. So what have I got here? Second y is 60 minus first y 45, right? And then I have second x 13 minus first x 6. So if we can subtract those, combine those, we got it. 15 on top, right? Over 7. Okay, so yeah, this is probably a point. Let's go ahead and round that. Divide that, actually 15 divided by 7, and it's not a whole number or a nice terminating decimal. So we'll just say it's approximately with a little wiggle line there. I think it's 2.14. Is that right?
Yes.
2.14. Thank you. What I have for papers, I just want to make sure. Okay, so that's our slope. Which we did last time. However, we want to apply this a little differently here. Think about it a little differently. Let's think about, so I've got my slope. We haven't talked about units of the slope here, but that is another thing we could talk about. In this particular case, all right, look at how we obtained this slope. All right, so we took the difference of the y's on the top, and then we took the difference of the x's. And so the units of my slope are just going to be the units of the y divided by the units of the x. Does that make sense? Because that's exactly, how I get the slope. I do the y's over the x's, right? Well, what are the units of y here? Well, the y's are the 45 and the 60. That's inches, right? So the units of y here are inches. And then the units of the x, that's age. Well, of course, I didn't put it there, but of course I mean years. 6 years old, 13 years old. Year. The reason I mention that is because this is where we get this idea of, or one way we can see where this idea of rate of change here, because another way, so it's inches over year, or inches per year. Sometimes you read something like that as inches per year. Right? Sometimes that's where you can read that. Okay, and so putting that together here, so I've got 2.14 inches per year. inches per year. So what this is, what this slope is this gives us, so this 2.14 inches per year with the units now, that's this what we could call this average rate of growth. I mean, it's positive, and so we're talking about growing. Here sometimes it'll be negative, so it's decreasing, but that's another way we can interpret this. 2.14 is the slope, but we can also interpret it as 2.14 inches per year. In other words, that's our average growth rate. Now, why do we say average growth rate? Because do you think this child grew exactly 2.14 inches each year? Probably not. You know, they go up and down. You know, you don't grow necessarily steadily. Some maybe do, but so that's why we're saying an average growth rate. If we took all their growth rates up in, you know, each year, say child grew this much, and then the next year grew this much, and this is the averaging it out. So that's what you do. That's what you get when you do this slope formula. You get an average growth rate. You average all the years growth out. It'll come out to be 2.14. That's what this is saying. Okay, so slope can be interpreted as this rate of change. In this case, is a growth rate. You know, we'll talk about another couple of examples, but one of them is, you know, growth rate. So slope can be interpreted as the rate of change. Average rate of change, I should say. So to put this in a, I mean, it's kind of right there, but another way, so the interpretation here, so this, what is the interpretation of the slope being 2.14? So it'll ask you sometimes about that. So what's the interpretation of our slope being 2.14? Well, like we said, we went through it here, but that tells me that the child grew 2.14 inches per year on average. So that's kind of the phrasing. If it says interpret, all right, that's kind of the phrasing you use. Now, of course, the units in other examples will be different, maybe different. Usually it'll be a time, but it doesn't have to be a time. But, okay? All right. So, that in mind, here's another one. Find and interpret the average rate of change from this graph. All right, so we got a graph. It's just the first quadrant graph, but it is an XY graph, and treat it that way. All right, so along the bottom here, we'll have the years. And we're just going to have, I'm just going to do 1, and then 3, and then 5. Space them out that way. All right, then over here I'm going to go in 5s. This one's 5, 10, 15, and 20. And that stands for the value of a car. And it's going to be in thousands of dollars. All right, here's what I've got. Year 1, I've got 20. Year 3, I've got 15. And year 5, it's 10. All right, well, that's a lot of details there, but so far so good. It's just a graph, and we're just labeling it with years for the X, and then. All right, now, on this particular one, okay, so the average rate of change how do I get it? Well, we said the way you get it is you just need the slope, right? Now, in this particular case, all right, so slope, we can do that a number of ways, right? We can do the slope using our slope formula. But in this case, since we've already got it graphed out, let's do it the other way or another way, and that is rise over run, right? So we could do it with the slope formula. So if you do it that way, that's fine, but let's do this one another way. Maybe it's a little quicker way. Do it rise over run. So the rise over the run here, so it's just from point to point. Now, it's a little kind of misleading here, but all right, so here's my rise, which actually is down, but it's considered the rise. It's actually down how many? I go from 20 to 5, 20 to 15, which is down 5. So my rise would be -5, right? Because I'm going down from 20 to 15. And then my run, how much is my run? Well, I'm going from 1 to 3, that's 2, okay? So I'm down 5 and over 2. So that's my slope.
So if you go to the first one, you don't have to go all the way to the end.
No, you don't have to go all the way. I mean, it's the same.
Same thing.
Yeah, since it's a line, it's going to be the same. I mean, you could do this to this, but you're still going to get the same, which is -2.5. Now, this, not quite complete here because, all right, so just like on my, when I was doing the heights of the child, all right, so in that case it was inches over the years. In this case, what is it? Well, what are the Y's here?
Value of the car.
Value of the car. Dollars, thousands of dollars. So this is actually -2.5, but it's -2.5 thousands of dollars, right? Per, and then the X here is the gas years per year. So that's my average rate of change. The Y's over the X's, and so that's my average. All right? Now, so that's the finding part. What's the interpretation here?
The value of the car goes down 2.5 thousand every year.
The the value of the car goes down $2.5 thousand, or decreases. I think some of the problems in the book, homework problems, they'll say decreases or increases. So the value of the car decreases, goes down $2.5 thousand each year, on average. Okay, so it's just, again, just putting some words to the calculations here on the chart. All right? Let me do one more here. This one's, again, just a little different wording. All right, so the average price of a movie seat in 1990 was $4.23. In 2012, it was $7.96. As you know, ticket prices went up. Usually do. All right, so again, same instructions. Find and interpret the average rate of change. All right, so again, this is putting in a little different format. We looked at it. This is more like the first one, isn't it? We did. It's given in kind of word format, sentences. So one idea would be, let's put it into pairs. All right, so I've got 1990, 423, right? So that would be 1990, comma, $4.23, or 4.23. And then 2012, so that'd be 2012, comma, the Y would be 796. So this one, unless we want to graph it, the way to go here would be the formula, right? So the average, again, the average, how do we get the average rate of change? Well, that's the slope. That's what we said, one way we can find it. So it's just asking for the slope. We're just asking it as the average rate of change. So in this case, since I've got the points, let's use the slope formula. The y2 minus y1 over x2 minus x1. Yeah, so it's just another calculating the slope here. So you do the y's first, so 7.96 minus 4.23, right? And then the x's, all right, so it'd be 2012 minus 1996, 1990, sorry. Whatever that is. 7.96 minus 4.23, 3.73 over 22. Again, probably, yeah, this is where we definitely want to go with the decimal. 0.1695. So we're talking about dollars here, right, again, so it would probably make sense for two decimal places, 0.17. So when we go with the rate of change, we need the units, all right? So what are the units here? Well, it's, again, you know, since we do the y's over the x's, we do the units of y over the units of x. That's always the way we typically do these. So the units of Y is just dollars, right? So it'd be dollars per units of X, just years. I think there is one in the book where they do months, but you just have to watch years or months. So that's my average rate of change, right there. 0.17 cents per year. Okay? So how do we interpret that? Well, again, the same basic way. We're talking about ticket prices, and so this is the average rate of change. So the ticket prices increased. This is the interpretation. Ticket prices increased 17 cents per year on average. And I guess we could throw in, I'm going to get real fine detailed here, from 1990 to 2012. But something like that. Seems like they've been going up more here lately, right? All right, we good there? Question or concern?